165. For this week, we'll be going through Module 10, Designing Visualizations with ggplot2. So, what is ggplot2? ggplot2 is a package developed by Hadley Wickham in order to create a more intuitive way of developing visualizations from our data. The ability to create visualizations that embed meaning to data is a key step in being able to communicate information and findings to others. ggplot2 offers programmers a new way to construct graphical figures out of different visual elements using a grammar of graphics. So, what are a grammar of graphics? Well, grammar of graphics is very simple, and that was its point. So within grammar of graphics, we have multiple things to take into account. We have the data being plotted, usually in the form of a data frame. We also have geometric objects that appear on the plot. And these are different geometric objects like circles, lines, dots, squares, asterisks, whatever you want to create. And what those do is they actually take the place of different data points in the variable for visualizations. We can also map aesthetics to those geometric objects. Mapping aesthetics from variables into data to those aesthetics. And what that means is that with the geometric objects, may it be points or circles or lines, what if we wanted to change the characteristics of those points depending on the value of some other variable inside the data set? Well, we can do that. We can do that, and we can map those aesthetics to change the color, the shading, the shape, or other different types of geometric properties of geometric objects depending on some variable. We can do that using aesthetic mapping. We'll go through examples of that soon. As well, we can also adjust the position of the elements in the plot. We can scale each aesthetic mapping used. And what that means is we can not only use a linear scale, but we can use an exponential scale. We can use logarithmic scales. We can use dates. All these different scales can be used to offer more valuable meaning to our visualizations. We can also change the coordinate system used to organize geometric objects. The coordinate system will normally be in Cartesian coordinate system, or as you're more familiar with, having an XY axis. However, we can also use cylindrical coordinate systems too, and that would be useful when making pie charts. There are other coordinate systems available. We also have facets of groups of data in different plots. What facets are multi-panel plotting. That is, we can make 4 plots in the same figure, and that would be useful if we're comparing different scenarios or different times, and we're trying to make some sort of visual conclusion or ascribe some sort of correlation between data and under different conditions, and we can explore that using multifacets. Before we get into some of the examples, let's first go over what we're required to do this week in Module 10. This week we'll be reading Chapter 16 of Programming Skills for Data Science. That goes over ggplot2. As well, we'll also have a graded discussion 10, which will follow the same rules as grid discussions 1 through 9. We will also have exercises. These exercises are provided in order to help you master ggplot2 for subsequent labs. Let's get into some examples and dig in. For the first example, we first need to download ggplot2. Let's load this into our environment using the library function. Next, we also need a data frame in order to plot. Let's use the Star Wars data frame from the dplyr package. Notice how I'm labeling this as a data frame, or I'm downloading the Star Wars package without loading the dplyr package using the dplyr and the double colon notation. Let's load this up. When we load up Star Wars, we can view it and we can see that it has a lot of different types of variables related to each character inside the Star Wars saga. You should be somewhat familiar if you watched the video from last week about this data set. Now, let's give some examples. For the first example, we'll use histograms. Now, in this example, you can see here that we have done a few things. The first instance of the grammar of graphics is the data being plotted. That's stored as the argument for the ggplot function. You can see that here. ggplot argument, Star Wars. ggplot2 is interesting in that we're able to link together layers of our plots using this plus sign notation. And what that means is that the first thing that we include in ggplot is the first layer. The next one will be the second layer. We're adding that on top of it. And the third one will be the third layer. We can add as many layers as we want, but we need to consider the fact that as we add more layers, it might cover up other layers that were previously used. So in this example, we also see the geometric objects. The geometric objects are called by using the geom function. We have geom histogram, geom box plots, geom violin, geom bar charts, geom points, and as well as many others, different types of geometries that we can use. Now, when we make these geometric objects, the power of the grammar of graphics, or ggplot2, is that we're able to map aesthetics to those geometric objects. Now, we can create these aesthetics using the mapping argument. And we can do that using mapping equals AES, and then have what types of variables we want to include to ascribe to this histogram. And by saying this, we're saying that we want to take birth year, and that can be found right here in the data set. It gives the age of each of the characters. So we can calculate birth year, and we want to load that as a histogram. And basically what that means is that we're going to count the amount of times that people are a certain age, and we're going to map that as a count value. You can see here that after mapping, we close off our mapping so that we can give absolute values to the plot. And you can see here that we use NA remove equals true. I almost always recommend using this type of argument when calling on the geom function. It'll automatically remove and filter your data set to remove all NA values for the variables that you're plotting, which is helpful and saves you time from being able to do that prior to mapping. We can also see we have other options like bin width, and that corresponds to the width of the histograms itself. If we increase bin width to, well, let's say 20, then we will have a pretty fat bar chart or histogram. We can also use fill equals blue and then color equals light blue. What that means, and you can, if we zoomed in here, the outer edge or the color is light blue, and then the inner edge and then the inside is called blue. It's important to note that blue and light blue 3 are not automatically available in R, but instead I've defined them because I like the way that those colors look, and I've defined them using as such here. If we wanted to perhaps use the default colors that R offers, we would encapsulate that using quotes. You can see here that that's a much different blue. I'm not really a fan of that blue, so I've created my own blue, stored it in a variable called blue, and that's what we see here. You can also see that as we add different layers, we can customize some of the titles. We can add a title, histogram of age distributions of Star Wars characters, age and years as the x-axis, and y in counts. If we didn't do this, the x would simply be referring to the birth year, and it would be spelled out exactly as such. And the counts would also be a lower count counts. I like it uppercase. So for another example, let's go through a box plot. In this box plot, we can see that this also adds a new layer of sophistication to our modeling of single variable plots. And what that means is that we also have other information, not just related to the static counts, but also related to the statistical distributions. You can see here that this line right here is the mean. The box represents the standard deviation from the mean. One standard deviation. Anything outside of that box is an outlier or something that's greater than one standard deviation around the mean. This is useful if we're doing some sort of statistical analysis and we want to visualize the power of that analysis or such. Not the power, but some of the distribution of it. So you can see here that in this Star Wars, or in this example, for the data being plotted, we are not only including Star Wars, but we're also subsetting. We're allowed to subset this data frame, as we subset this data frame, it gets input, and ggplot only uses the data frame output from that subset. So here we're saying that we don't want to include a gender equals none, and we don't want to include any NA values. This NA value is somewhat redundant because we're also using the NA remove equals true, but I wanted to provide it as an example to show that there are multiple ways to remove NA values prior to plotting. We can see here that for geomplot, and this is the type of geometry, the geometric objects we're plotting is the box plot. You can see that we're including a mapping of an aesthetic mapping. It's important to note that I included mapping equals aesthetic here, and then aesthetic right here to show that when we call on geom functions, the first argument is assumed to be, or the first positional argument is assumed to be an aesthetic mapping. And so on the x-axis, we have gender, and then on the y-axis, we have height. And you can see here that we're not changing the color depending on some sort of variable, and we're making it blue. Now, what if we wanted to change the color to make it something else? Maybe we're also using height, and perhaps we want to change the color depending on the species. Well, we can do that. Species is not capitalized, so instead of having color equals blue here, just ascribing a general color to all the plots, we can make it variable depending on the value of some other variable in the set. So let's say color equals species. Now you can see that when we do this, it's kind of all over the place because we have so many different species inside of the Star Wars universe. However, it does give some approximation for the fact that we can create these different mappings depending on what variable we use. For species, maybe because there's so many species involved, perhaps that's not the best idea of doing that. Perhaps, maybe what we should do is we should use eye color. There's less values for eye color available, at least I'm assuming. So let's try that, eye color. Well, there's also a lot of eye colors here too. We'll go through some other examples of mapping aesthetics depending on it, on the values. I also want to point out that this box plot really doesn't give you a lot of information aside from the fact that it seems very scattered, and that's because we're changing the color based on eye color. And what we're doing is, first of all, we're checking to ascribe similarities between gender and heights and find those averages and the standard deviation of heights according to each gender. But we're also changing the color based on the eye color, which implicates that eye color may have something, maybe somewhat to do with height, and that's absolutely ridiculous. It doesn't. When we use species, though, that would be possibly make sense for visualization. For another example, we can go through violin plots, and you can see here that we also subset. We included a new geometric function or mapping, violin. We map on the x-axis equals gender, and the y-axis equals height. And it's important that if we want to plot variables, we have to include them in this mapping aesthetic. We're making the default color of them to be blue. We're removing all NA values, and we're ascribing title, x-axis, and y-axis labels to the labs. Stands for labels. Now there are a lot of different types of geometric functions, and in one of those examples, I went through how we can change the coordinates from a Cartesian coordinate system to a polar coordinate system or a radial coordinate system, and that's how we're able to actually create this pie chart. We're going about based on the radius, so it's ascribing or the actual pie slice. One of the most useful ways of plotting, and probably one of the most common plots that you've seen, is probably a scatter plot. You can see here that we have a scatter plot of height of all the Star Wars characters on the x-axis and mass. And what we normally want to see here is that as we increase height, they're also going to weigh more. We can see that in real life. Very tall people tend to weigh more than very short people. This is normal. They have more mass. However, we can also see here that this is strongly this association between height and mass is strongly masked by this outlier, which is an extreme amount of mass. It's like 1,400 units. I'm not really quite sure what units they're using in this, but it's about 1,400. Um, this is Java the Hutt, so he's very heavy. And perhaps he's an outlier to the rule of height versus mass. And if we wanted to remove that, we can we can exclude it by subsetting it. So the way that I'm subsetting this is I'm saying which is the max for Star Wars mass, and I'm using the negative sign to say don't include that. And so what happens when we subset that? Well, you can see here that we have, now we actually seem to have that association a lot better. As an example of how we can use aesthetic mappings, let's say that color equals gender. Now this makes more sense. Now we can see that each of these values for what corresponds to a male versus height, and perhaps we can learn a little bit about the Star Wars trilogy that way, or the Star Wars universe. It's not a trilogy. You can see here that Star Wars, they mainly, it seems like most of their female characters are within a specific profile, height, and mass. And we can also see that there are many more male characters than female characters in the Star Wars. This might be indicate that they were targeting a specific audience when they were trying to include these female characters, and that audience was probably primarily male initially. And then you can see here that there's a wide distribution in the male gender. You can form whatever conclusions you want out of that independently. But this concludes the short and brief vignette on ggplot2. If you have any other questions, please don't hesitate to ask. And it's important to know that this is a very limited example of the possibilities that you can do with ggplot2. More examples are visualized inside of Chapter 16 and Programming Skills for Data Science. And it's important to note that we can do a lot of different things with these visualizations, including making maps, which are discussed in there. And we will be doing that for one of the labs in subsequent weeks. Thank you, and that concludes the Module 10 vignette. If you have any questions, please don't hesitate to ask. I'm available by email, phone, or Zoom. Thank you. Have a great week.